So, good afternoon, everyone. Good afternoon, ma'am. I am John Lloyd D. Patricio, and I am reporting the study of Guanzon and Magtoto, which is efficacy of seaweed extracts as biostimulant on growth and yield attributes of peanut or Arachis hypogaea. So, let's proceed. Peanut has been widely grown due to edible and oil biological fixation. However, peanuts are susceptible to fertilizer burn. Thus, balanced fertilization is a crucial crop management to elevate crop yield and quality. Legumes require large amounts of agrochemicals to increase and achieve potential yield. Since year 2021, the cost of synthetic fertilizer has more than doubled. An alternative method of reducing the use of agrochemicals is the introduction of seaweed extracts as an eco-friendly approach to the production system, which is De Filippo Herrera et al. 2019. Seaweed liquid fertilizer can stimulate crop growth while providing a range of high and medium micronutrients, including polysaccharides, amino acids, vitamins, and other active ingredients, while biostimulants are organic natural compounds that provide crops with nutrients when combined with other fertilizer, perhaps enhancing growth and output, which is Abat et al. 2020 and Meng et al. 2022. Using seaweed as a biostimulant is an alternative and holistic approach to resolving agro-environmental crop production issues. So, let's proceed to materials and methods, experimental site and planting materials. At Castillo, Concepcion, Tarlac, Philippines, wherein the area has a type 1 climate with 2 seasons, the dry season from November to April and the wet season throughout the rest of the year. This study used peanut seeds, which is kalbo, with a maturity period of 80 to 90 days from planting. Experimental design, treatments, and layouts. A randomized complete block design or RCBD consisting of 5 treatments and 4 replications. The experimental plot size was 4 meter by 3 meter. Crop management. Area of 441 meters squared prepared by plowing and harrowing twice and pulverize the soil. Before planting, 40 grams of inoculant, which is rhizobium, was mixed in 2 kilograms of peanut seeds until the seeds were evenly coated with inoculant. This was followed by planting 2 peanut seeds per hill with a planting distance of 20 cm between plants and 50 cm between furrows. Seaweed extract application. Foliar application of various seaweed extracts was applied in different stages of the plant. R1, initial flowering or 27 days after plant emergence, and subsequent application were made at R2, beginning of the pegging. And R3, which is pod development, treatment application were calibrated individually in every 16 liter of water and applied during the early morning. So here we have 5 treatments. So treatment 1, which is negative control or water alone. Treatment 2, positive control, RR67 3030 of NPK. Treatment 3, Capophycus alvarezi 12.5 ml. Treatment 4, Cottony spinosum and sargassum 10 ml. Treatment 5, brown kelp mass 15 ml. So, materials and methods. Data collected from the study were analyzed and compared through LSD at P less than 0.05 using STAR software. Significant variation in growth and yield related traits of peanuts among different treatments were assessed using analysis of variance or ANOVA. So let's proceed to data to be gathered. Plant height and days to flowering. The 10 sample plants were randomly selected from each treatment and measured at 30 and 60 days after sowing for plant height by centimeter. In contrast, days to flower were recorded when at least 75% of sample plants could produce flowers in every treatment. Yield-related traits: pod number, shelling percentage, weight of 100 seeds, pod yield, and harvest index. 10 sample plants from each experimental unit were uprooted to measure yield-related traits such as pod number, shelling percentage, the weight of 100 seeds, pod yield, seed yield, and harvest index. The values of these traits were counted and averaged for further analysis. So let's proceed to the result. Table 1. Effect of various seaweed extracts on plant height at 30 and 60 days after sowing, and days to flower on peanuts. So this table shows that the recommended rate of fertilizer, or RRF, which is positive control, greatly dictates the plant height for 30, which is have 24.09 plus minus 3.64 centimeter, and 60 52.77 plus minus 2.38 centimeter days after sowing. In contrast, the plants treated with seaweed extracts and those treated under negative control were statistically not significantly different. On the other hand, the number of days to flower in peanut was shortened by applying both Capaphycus alvarezi, which has 23.50 plus minus 0.58 days, and Cottony spinosum and sargassum, which has 23.75 plus minus 0.96 days, respectively. At the same time, plants treated with brown kelp mass, which has 24.75 plus minus 0.50 days, showed a comparable result to Capaphycus alvarezi and Cottony spinosum and sargassum. In comparison, treatment under positive, which has 25.75 plus minus 0.96 days, and negative control 27.25 plus minus 0.96 days, delayed the number of days to flower in peanuts. So let's proceed to table 2. The number of pods per plant and weight of 100 seeds as influenced by different seaweed extracts as biostimulants. So this table indicates that the pod number in peanuts substantially increased by applying different seaweed extracts compared to the positive and negative control. The number of pods increased by at least 76.33 to 78.52%, average of 9.25 pods, when plants were treated with various seaweed extracts compared to the control plants. Plants sprayed under seaweed groups such as Capaphycus alvarezi and Cottony spinosum, sargassum, and brown kelp mass produced the heaviest seeds with an average value of 44.55 plus minus 0.54, 45.12 plus minus 1.46, and 41.88 plus minus 1.38 grams, respectively, while RRF had an average value of 38.35 plus minus 0.93 gram, followed by negative control, which had the lowest 100 seed weight of 34.48. So, in Table 3, agronomic yield trait of peanuts influenced by various seaweed extracts as biostimulants. So, in Table 3, which is agronomic yield traits of peanuts influenced by various seaweed extracts as biostimulants. So, in this table, regarding seed yields, various seaweed extracts were found to enhance crop output. For instance, plants treated with Capaphycus alvarezi produced the maximum seed yield of 1.71 plus minus 0.17 tons per hectare. Cottony spinosum and sargassum yielded 1.67 plus minus 0.20 tons per hectare, while brown kelp extracts produced a 1.65 plus minus 0.13 tons per hectare yield. The positive control yielded an average value of 1.07 plus minus 0.15 tons per hectare, while the negative control had the lowest seed yield at 0.91 plus minus 0.12 tons per hectare. Additionally, the harvest index in peanuts did not show significant differences among the seaweed extract groups, but it was enhanced compared to the positive and negative controls. Similar findings were reported by Damarde et al. Year 2020 and Kurakula and Rai 2021, indicating that seaweed extract can significantly increase the harvest index in peanuts and chickpeas. So let's proceed to the result. Superior plant height at 30 and 60 days after sowing was observed in positive control with values of 24.9 plus minus 3.64 and 52.77 plus minus 2.38 centimeter, respectively, compared to the other treatment, P less than 0.01. Consequently, all seaweed extract significantly influenced P less than 0.5 various peanut parameters, including the number of days to flower, number of pods per plant, 100 seed weight, shelling percentage, pod yield, seed yield, and harvest index. Notably, the application of Capaphycus alvarezi significantly P less than 0.001 increased pod yield 2.42 plus minus 0.26 tons per hectare, and seed yield 1.71 plus minus 0.17 tons per hectare compared to the other treatments. So the study concluded that various seaweed extracts could be an alternative eco-friendly bio-based stimulant for peanut production. Compared to the other treatments, superior plant height at 30 and 60 days after sowing was observed in positive control. Consequently, the number of days to flower, number of pods, the weight of 100 seeds, and pod yield, seed yield, and harvest index were significantly enhanced through the application of seaweed extracts as compared to positive and negative control. Applying seaweed extracts, particularly Capaphycus alvarezi, significantly improved the growth and yield related traits of peanuts. Therefore, utilizing natural extract derived from macroalgae can serve as an alternative to synthetic inputs to enhance crop productivity. So that's the end of my report, and thank you for watching.